Okay, class, so let's take a look at this homework. I'm not going to go through and give you every single one, but I am going to give you a lot of tips here. So wise idea to watch through the end, especially before we grade and look at homework tomorrow. So number one, a movie theater can hold 234 people. They make $3 per person who come into the show. So similar problem like our flowers, right? Except now we're talking about a movie theater. If you're not sure which one should be your X, right? We said we could either look at making a table or we could write out the function rule. So we have Y equals $3 per person. Okay, so our X is going to be our per person, which means our X is our people. Our Y is going to be our money. If you think about that in a table either way. Okay, so when we're talking about a reasonable domain, we're talking about the number of people. Okay, so the number of people who can come into the movie theater, well, we could have no one show up. We could have 100 people show up. We could have 234 people show up. But we cannot have 235 because once we get to 235, we no longer have space, right? The max number that we can have is 234. Now, we can't have half of a person, so you might also say that this is our whole numbers between 0 and 234. Okay, right? There's multiple ways we said we could write that. We're not going to be super picky on that end. Just make sure we're not including any negatives and nothing larger than 234. Okay, then for the amount of money we can make, we need to consider, okay, well, what does happen if 0 people come? If 0 people come, we make $0. Okay, and we can have up to 234 people come. So if we have $234 times 3, right, then we're going to make 702. So we know our Y value can be as small as 0 and can go up to $702. Again, this is something where we could say that we're counting by 3. We could say multiples of 3, something of that regard. Again, not necessarily needing you to be that specific, but making sure we're understanding that's what's happening there. Okay, number 2, a teacher can grade 1 test every 5 minutes. Putting that into perspective because it's kind of realistic. So every time you take a test, we're spending at least 5 minutes grading. Okay, so if we're looking at this, right, time is always our X if we have it. So we know we have an X of time and a Y of number of tests. We don't really need to write the function rule. We just need to think about what those mean in terms of what's reasonable. I can work for 0 minutes. I can work for 5 minutes. I can work for 100 minutes. I can work for any amount of positive minutes. So my domain can be anything greater than or equal to 0. You could say it's all of our positive numbers. Okay, if I grade for 0 minutes, I can grade 0 parts of a test. If I grade for 5 minutes, I can grade 1 test. It's okay for me to have 1.5 tests graded. So for my range, I can grade any number of tests greater than 0, right? I can't grade 0 tests. I can't work for I can't grade negative tests. I can't work for negative minutes. So those both have to be positive. Okay, number 3 is very similar to the one we looked at in our notes. It's just an ellipse. It's that sort of oval shape instead of circle shape. So I'm not going to do that one for you. Number 4, we need to make sure we consider on number 4, right, that this line has arrows. So it's going on forever and ever and ever. Same thing over here, which means it's going to continue going out and out and out on that x-axis. So when I'm looking for places that this will fall and touch my x-axis, right, this is going to come and fall down and touch here, touch here, touch here, touch here, touch here, right? This whole entire x-axis is going to get touched. So my domain is going to be all real numbers. Okay, for my range, I'm sort of thinking the same thing, but now I'm kind of going the opposite direction, right? I kind of want to think about where it's rising or falling and touching on my y-axis. So this can come down and touch here. This can come up and touch here. Either way, these can come up and down. And so I'm getting this area touched, but I can't ever go below 4. No graph is happening down here. So my range means y is going to be greater than or equal to 4. Okay, 6 is going to be a very, oh, I somehow have a backwards numbering. Sorry, sometimes it auto formats. Weird. Okay, 5/6, because I numbered it wrong, is going to be very similar to number 4. So you want to think about those exact same concepts, just instead of it coming down at a precise point, right, it sort of angles out. But these are still going to keep coming out further and further no matter how far you go. It's going to happen slower and slower, but it's still going to happen. Okay, number 6, again, if we're looking at our domain, okay, so our x-axis, right, the graph can come up and touch here, it can touch here, it can touch here. It already touches in all of these places. It can't go any further. So anywhere in this set, that open circle doesn't really mean a whole lot because it's filled in right there. Okay, so our x, or our domain, it's going to be anywhere from -6 to 6. We're using x because it's our domain. They're filled in circles, so we can use the or equal to on the 6 and -6. Now our y is going to be quite a bit more tricky, because if we flip our paper and think about where this melts down on the graph, it only melts here and here, which means y can only be 2 values, right? Our range can be 0, 1, 2, or -3. That's it. Y can only equal 0 or -3.